So there's like a bazillion million problems on the board. Generally, that's good news for you. What does that mean about these problems if there's like a million bazillion example problems to cover?
Are you seeing a
They're
lot
probably
of
all quick, easy hitters. There's a lot of variety. I guess the only thing that can mess you up, but in terms of difficulty level, they're all pretty quick hitters. The beginning of this, from here to what as far as the camera could probably see for now, this is just like an old refresh. None of this is in the new homework. This is just trying to refresh some ideas that used to be in there in chapter 1 and 2, and that we're hoping is still there. So this chapter has a bunch to do with these things, which are called exponents. A synonym for exponents. Exponents can also be called
square, cube,
we can get to that in a second, yeah.
power.
Powers, exponent and power are synonyms. Anybody remember what this big number at the bottom is called? It's a B word.
Base.
It is the base. So we have a base, we have an exponent, we have a power. 3 to the 5th, we should remember, means that we want to do.
3 times 3 times 3 times 3 times 3.
And just do out that math. Vivian mentioned squared and cubed. Which one is which? Somebody else, because she was doing all the talking so far.
The 2 is squared.
The 2 is called being squared. The 3 is called being cubed. Those are all things that we had once upon a time. Question about that. Still old days. We had some rules in the old days about if we had negatives in parentheses go into certain powers, certain things happen. Does anybody remember a rule about that? Negatives in parentheses go into powers, some breakdown options. We did some vocabulary quizzes on this back in the day. I don't remember which chapter, but it was definitely in the fall.
What does the first one say?
This says, I didn't fill in anything yet, but it's negative to a certain kind of power does a certain kind of thing.
If the negative is inside the parentheses and the power is outside, you leave it as negative.
Depends on the power type. There's 2 options.
If
Sometimes we do a negative to a certain power and it comes back negative. She is right on that. But there's other times there's a negative and a power out here and it ends up coming back positive.
it depends on how many times.
It does.
If it's even, it's going to be positive. If it's odd, it's going to be negative.
That's correct. Anytime there's a negative in and it's an even power, we'll get positive. Anytime there's a negative in and it's an odd power, you're going to end up getting a negative back. We had some other rules about exponents of this to a certain power would always do this or that or the other thing. Does anybody remember a ruling on powers? If you have any number in the universe and it goes to a certain power, there's a couple rules about certain things that could occur.
Something to the power of 2 will always be itself. Will always be.
And there is something to a certain power that'll always be itself, but not the power of 2. If we go power of 2, we'd have to do a multiply problem. Power of 1. Anything to a power of 1 always comes back as itself. So over here, this 2 to the 1, that's just a 2.
Anything to the power of 0 will be 0.
Anything to the power of 0 is something, but it isn't going to be 0. It won't be itself.
Is it 1?
It is 1, and I'll explain why in just a moment when I build this big pile of numbers over there. Does anybody remember what negative powers do? It doesn't. Let me come back to that after we build this stack. So let me build up here. 2 to the first power is 2. If I do 2 to the second power,
2 to the second power would be 4.
would be 4. 2 times 2. 2 to the third power
8.
is 8,
16.
16,
32.
32. So as we build up the tower, what was happening each time?
We were doubling it.
We multiplied by 2 because 2 was the
Base.
base. If the base were a 3, we would have been
Going through.
multiplying by 3s. Okay, but as we move up the tower here, we multiply by 2. So how would we move back down the tower?
Divide by 2.
Divide by 2. So if we're moving down the tower dividing by 2, the only thing that makes sense for this to be
Is 1.
is 1. Anything to the 0 power is 1. Because if we were doing threes, we'd be going 3 times 3 times 3 times 3 times 3. To work back down, you'd have to be dividing by threes. You'd have to have that 0 power be 1, or else the whole system just falls apart. If I go down another level, what would 2 to the negative 1 be? How are we moving down the column?
It would be negative 2.
How are we just moving down?
Dividing
by 2.
0.5.
So divide by 2, we'd get a half. Divide by 2 again,
0.25.
or a fourth. Divide by 2 again. Am I still on the screen, or did we lose me? Little turn, thank you. Divide again. We're at a fourth, and we're dividing it by 2.
0.2. 0.3.
I think fractions will go better for us.
1/8.
1/8, which would turn into
1/16.
16th. It's like working on the inches ruler, or just keep dividing a cake into pieces or something. 1/32. Look at the fractions we just made. Compare them to the numbers I started in the beginning. What's the relationship here that's happening?
The denominator is the same as the
Yeah,
answer.
the denominator is the same as the old answer. These are buddies. Those, these. It's getting pretty zigzaggy. Those, these. So what negative powers do, they didn't make anything negative. Everything was positive there. What negative powers do is flip things. Negative powers flip things. So you get a 1 on top, and you get your variable thing on the bottom. Negative powers flip. They don't make things negative. Well, that's old. Is this going to affect your homework life tonight? No. Could it affect your chapter at some point when they're asking you to do something out? Yeah, maybe. It's just good things to remember and know. Then I got a stack of things that are negatives involved. Again, this is not affecting your homework life. The homework will kick in when it says the word right. That's the notes that will affect your homework life. But once upon a time, we took a test, and it had these 8 questions on it. And it came down to, you had to count how many negatives were involved based on just the rules at hand. Anything with 2 to the third has something to do with the answer number.
16. No, 8.
2 to the third is 8. So a minute ago, 2 to the third, this has to do with 8. This has to do with 8. This is 8. This is 8. Are we captured to there? Corey, can you see from where you sit? Does it capture me to the 8s thing? Okay, so we shouldn't be good.
Yeah,
We're good still. Anything 2 to the fourth has something to do with 16ths. So these answers all have something to do with 16ths. It's just a question of whether they're negative or not. So we're back to Vivian, I believe, made the observation. If we have an odd amount of negatives, we're looking to go negative. If we have an even amount of negatives, we're looking to go positive. So if I write the problem this way, the 3 goes with this. That's how we got the 8. The 3 also is trying to get with negative. So there's an odd amount of negatives on this one. So this would be
negative.
negative. How many negatives does this one have?
Is that say
4.
4?
4 is an even number, so
It's going to be positive.
it's going to be positive. How many negatives does this one have?
That's a 3, right?
That is a 3.
And then 4.
So it has 4. 3 of this and 1 of that. 4 of them makes it
Positive.
positive. How many does this have?
5.
5. 4 of this, 1 of that. 5 of them makes
Negative.
negative. When I stepped over to this group for the final group of this, what did I do a little differently on the next?
You put the
2.
exponent on the inside.
I put the exponent on the inside, and I need to make a quick change on these. Right. So I think I got double quote. I'm gonna cut it. How many negatives on this one?
2.
2. 1 of this, 1 of that. The 3 only goes with
Number it's
the
touching.
number it's touching, so that's positive. How many does this have?
2.
2, so also positive. That's old. That's memory lane. Good stuff to know. Makes the final. Not really making the homework. Question about what's up with any of that. So here's the first bit of new knowledge is they'll give you something and ask you to write it in factored form. And that's not going to be too tricky, I don't think. Probably need a turn. See if you can capture from right until the finish line. One turn and capture all of that.
Ooh. I think I went down a little too far.
Yeah, we'll take that.
Oh my goodness. Okay.
We'll capture from there to the very end and be done turning.
Oh my gosh, I can't get it straight.
It doesn't matter if it's straight. It's not a professional video.
Okay, if I do it like that, it'll get it
Okay.
farther.
Think we're good?
Yeah, I think that's
All
good.
Anybody have a thought if you're asked to write z to the third times x to the fourth in factored form, what that would even look like? I'll give you a hint. It's not hard.
What?
To write z to the third x to the fourth in factored form. What do you think you could write? And I'm dropping the hint. It's not hard.
Z times Z times Z, X times X times X times X.
That's correct. And what's the easiest way to show letters for multiplying other letters?
The dot.
You could use the dot, even easier than that.
You just put them next to each other.
Just put them next to each other. So that's like z times z times z, with or without a dot. X times x times x times x, with or without a dot. This is called factored form for that. All this is doing is demonstrating that you basically understand how exponents work. So that's a pretty easy hitter. So for this, what would you do about the b's?
3 B's.
3 b's.
One. Does that say
How about
four?
the a's?
Does that say 4?
This is a bit of a messy baby too.
Okay, 2 A's.
So 2 a's.
And then 1 negative 5.
And then just a single negative 5. The negative doesn't have a power on it, the 5 doesn't have a power on it, the 2 only goes with A, so just keep negative 5 and then some A's and some B's. Question above the line about factored form, that's where homework questions 1 to 4 or something like that will have you do a couple of them. And here's a pretty important vocabulary word. There's a thing in algebra called a monomial. Eventually we'll end up with a thing called a polynomial. Does anybody know what the prefix mono generally means?
1.
Poly is a different prefix, means
Multiple.
multiple, 2, 3, 4, 5, just more than 1. But we're going to start off today talking about monomials. The next bit of homework, we'll look at the homework page in a minute, I'll ask you just, is this a monomial, yes or no? So a monomial, the ruling is it could either be a real number, or it could be a variable, or it could be a product. Which product mean?
Multiple.
Multiplying those. So if you have multiplying, you're fine. If you have variables, you're fine. If you have real numbers, you're fine. Anybody remember from like the second or first day of school? I don't remember, but first week for sure. What were the real numbers?
Any number that isn't an integer or something.
Can they be decimals?
Yeah.
Yeah. Fractions?
No.
Yeah. Weird stuff like pi?
Yeah.
Yeah. The definition for real numbers back then was basically all the numbers you know. And that'll work until you get to Algebra 2, Chapter 7. And you'll learn a new kind of numbers that aren't real numbers. But for now, any number you've ever heard of or seen works. Variables will work. Product, meaning multiply those, that's going to work. And then across the bottom here, I listed 1, 2, 3, 4, 5, 6, 7, 8, 9 things that may or may not be a monomial. So we'll make everybody talk, because so far there's only been 1 or 2 voices appear. Pick any one. Either tell me it is a monomial or it isn't. I don't care. We have, I'll number them to make our conversation easier. 9, 8, 7, 6, 5, 4, 3, 2. There's not a number 1 because I miscounted. I thought I had 9. Oh yeah, here we go. That can be number 1. It's at the end. And is or isn't? Weigh in either way.
I think number 2 is.
Number 2 is a monomial because that's a real number. That's a thing you've seen before. You've seen a half. You've seen that number. So that is, yes, a monomial.
Number 7.
We'll just wrap around it a little bit.
Okay, so I'll say 4. I'll go 4, and I think that's
Is?
Yeah, I think it is.
4 is. That's a variable, and that made the list. Real numbers, good. Variables, good. If we're multiplying, we're good. What do you say?
Is 7 not a real?
7 is. Root 7 is a real number. X is a variable. Those are right now trying to multiply. That's all okay. Root 7 is kind of like a weird real number, but we've like heard of that before. It's a thing that we can do. You know, something in, something out.
5 is.
5 is real number, variable, variable, variable. Everybody's multiplying, so that makes the cut.
Is. What's the last one?
The last one is 4/5 x squared y cubed z to the 4th.
With that one? Come on. Well,
It is, yes, because we've got a real number, we've got a bunch of variables, they're all multiplying, so that is a yes. Back to you.
I think 6 is not. a
6
number.
is not, that's true. Why did 6 fail the test?
Because there's no actual numbers.
Yeah, it's variables. Variables are okay, but what is this?
It's divided.
It's dividing, so dividing is not in the list. Multiplying is a win, dividing is a lose.
So this is the question, is 9 0?
9 is 0.
Okay. I'm not gonna go now, I'm just gonna go 8.
Okay?
That is not.
8 is a lose. Why is that a lose?
Subtraction.
That's subtraction. Multiply is all that's allowed. This will be a thing we'll eventually get around to that's called a binomial because there's two. If you start adding or subtracting monomials, that turns into polynomials, binomials, trinomials, whatever that may be. But if I just said the x, you'd say
Yes.
yes. If I just said the y,
Yes.
yes. But as soon as I drop the subtract, it's a no. Save that for binomial, polynomial kind of thing. What do you say? We're left with 3 and 9.
I think 8 is a number.
This one?
That's a 0, right?
That is a 0. So yes, it is. Because 0 is an example of which category?
The real number.
It's a real number. We've heard of that number before. We've heard of 0, so that's a win. Leaves you with just this, Joyce.
no.
No, that's a binomial. What messed it up?
These two.
Yeah, and what did it do that we're not supposed to do?
Add.
That's adding. So we're only allowed to multiply to be a monomial. That's a binomial. So that's the second bit of the homework. Question about that. The third bit is the most important bit. So the main goal today is for us to learn and improve our skills about how to multiply when there's like bases and how to do that. So if I tried to take x squared and I multiplied by x cubed, before I tell you what the magic solution is, anybody willing to give a guess at what the answer will be?
X. Just 5 of them.
We could write it that way. What would be a better way to write it?
5x to the power of 5.
X to the power of 5 is totally correct. What she did is thought, okay, if we think factored form like we did a minute ago, x squared means there's xx. X cubed means there's xxx. So if we put that all together, there's 5 of those x's. That's x to the 5th. If you want to do it out that way, perfectly valid. That's how I was going to explain it in a minute anyway. But there's a way we can skip this and just cut straight to the answer. What's a quick way we can just cut straight to the answer? Just add the exponents. So if you're multiplying, anytime there's like bases, meaning who's the bases of these?
The x's.
The x's are like bases, they're the same bases. Just add the powers, and we're just going to copy the base the way it was. This used to be an x, it's still an x, don't change the base, just add the powers. So this would be simply
X to the power of 11.
x to the power of 11. Question about that. This I got a little bit meaner.
Actually, b.
That's 4.
Actually, plus
It is an x. We go a plus b. We want to try to add those, but they're called what in algebra terms?
Variable.
A U word. We can't really add them because they're
Unit.
these we can add because they're
Like.
Letters.
like
Or
terms.
something.
These you can't add them
Oh, they're
because
not
unlike.
they're unlike terms. So all you can do here is go A plus B and quit. What do you think about this?
What's that say, 7?
It's 3 to the 7 and 3 to the 4.
Is that one?
9 to the power of 11.
It is. I was expecting somebody to want to say 9 because 3 times 3 makes 9. This does not have a 9. We copy the base. The bases are the same. We keep the base the same. If we wrote this out, we'd have a whole bunch of 3's. And if we wrote this out, you'd have another bunch of 3's. You put it all together, there's still 3's. You're going to have 11 3's. You don't ever change the base. As you multiply, you just add the powers. Something like that. So this one, what do you think?
Is that a 6?
This is, these are both x's multiplying, that's a W.
What's W? Just W?
For sure the base needs to be
X.
x, so we have x's times x's, it's gotta be x's. And then I'm messing with you a little bit. What did I do?
W?
What did I do to mess with you?
You put another
One
X
exponent.
I didn't put an exponent on that, but there's one there. Who's there when I don't write it?
The 1.
It is a 1. So an unwritten exponent is a 1. So then what are we doing trying to add?
1 plus W.
1 plus W. Question about that one. Last one of that club.
X2 plus
Definitely
7.
keeping the x.
X2 plus 7, 2 plus 6.
I got it. That's a y. Y plus 2, y plus 3 is what I'm trying to write.
X
Y
y
plus
plus
5.
5.
Okay, there's a 5,
2Y.
2y. Because in front of this there's a
1.
1,
Another 1.
1. So if we're adding 1y makes 2y plus 5. Up to the line, anybody get confused by any of that business? And the last upgrade, and this will be it, I got 4 more here, and then I stashed one there because I was running out of space at the end, so I'm going to have to double back to this little area for that one. The last little thing they're going to do is sneak in a thing called coefficients. What are coefficients back again? We're back in the fall.
Coefficients went in front of the number.
What kind of number?
They went in front of
Yeah,
the
correct.
base.
So what are the coefficients on this?
The 5 and 6.
The 5 and 6. You could argue that they're bases, but I'd say they aren't really, and they're not the kind of bases we care about anyway. We only care today about like bases. So like x is a base for the 2, x is a base for the 6. If you do what you were doing a minute ago, the answer will turn out x to the,
Is that a 2?
that's a
8.
2. So this answer would go x to the 8. If I drop in some coefficients, you're just going to multiply the coefficients.
So you
This
get
5 is just like a regular old 5. There's no powers on it. This 6 is a regular old 6. There's no powers on it. 5 times 6, since you've been in like elementary school, 3rd grade maybe, has always been 30. That hasn't changed. So when you have these coefficients sprinkled in, do what you were doing to add the exponents on the like bases, but just multiply the coefficients. So here, coefficients will create
Negative 16.
negative 16. The x count is going to go up to
8.
8. The y count up to
5.
5. If that confuses anybody, it's probably because you forgot this had a 1, and 1 plus 4 made 5. This, coefficients,
60.
60, x,
6. Is that a 5?
that's a 3.
4.
4, because that's a 1, so we're up to 4. Y's, I got a 2, and I didn't write anything.
A 3.
So that's 3, because that's a 1. Question on those. And sliding back here, a theory on this one.
35.
35 from the coefficients. That's not an X, that's like a time symbol.
Oh, okay. And then 10 to the power of 8.
10 to the power of 8. Don't change the 10 here for the same reason. We weren't changing the X's here, we weren't changing the 3's there. These are bases, they're like bases. Don't change that, just add the powers on them, and that's where we want to go. I think we did a lesson maybe, or maybe it's in our future. Have we ever this year talked about scientific notation? Or am I getting my classes
think
crossed
so.
because I do too much math?
No.
Okay, there's a thing called scientific notation that's coming. Scientific notation things always have to do with powers of 10. But that's a preview of something that must be in our future. If no one remembers that, I'm
I remember doing it last year.
hallucinating. Maybe that's what I'm flashing back to last spring or something. Where we're headed, if you want to peek at the page or get the page even started, because there's still a good bit of time, about 20 minutes left. Homework, we're working off of page 228. 228 is going to work from 1 to 30. So what's up with this? 1 to 4, they just want you to write things in factor form. So that was like these two problems, pretty nice easy hit, 1 to 4. 5 to 12, they play the same game about monomials, yes or no. So we did 9 of those, the homework's going to do 8 of those, yes or no, depending on whether you have real numbers, variables, and stick for multiplication. Then 13 to 30 is going to be like what we finished when we hit like this corner of the world. You'll have bases with powers, keep the base the way it was, add the powers. If you don't see a power, there's always a 1. And if they decide to sneak some coefficients in the front of that, just multiply the coefficients while you keep on adding the powers. But basically from 13 to 30, it's like how we did that to finish. That shouldn't be a bad homework. That each of those should be a fairly quick hit. Yeah, anytime you're in math, you come in and there's like 60 problems on the board, that's probably a good sign. Anytime you come in and the notes are like 3 problems about mixture problems or something, that's probably going to be a bad day. If we're only doing 3 examples, it's probably like some fairly lengthy problems or something. That's all I got. The same button will stop it and start again.